Hello everyone, and welcome to the section 1.4 lecture, which is on circles. So, let's go ahead and get into it. So, we all know what circles are. We've drawn them for plenty of time, but let's talk about the picture version. You may not have seen them on a Cartesian plane, like on a rectangular coordinate system. So, I'm just going to draw the first quadrant like this. And I want you to make a tick mark on the x-axis called H, and a tick mark on the y-axis called K. So H and K are just some numbers. So let's go ahead and plot that point right there. And then, if I draw a circle around that, so that's a circle in the Cartesian plane. Here, go ahead and make an arrow to it. This is the center of the circle, and it's the point H comma K. And then, if you have any line connecting the center of the circle to the actual circle itself, that distance is the radius, which we denote r, lowercase r. Sometimes we denote it capital R, but lowercase r is what in most books we use. So that's the picture version in a Cartesian plane. So the question is, well, how should that correspond to a algebraic equation? So that's the next part, is the equation version. And here there are two different forms of it. The first form is the equation, I want to make this an actual definition. The equation of a circle in what we call standard form. So in standard form is x minus h quantity squared plus y minus k quantity squared is equal to r squared, where h comma k is the center, and r, not r squared, but r, is the radius. Now, it's a kind of cool thing, if you're curious, how this formula, like how we decided upon this formula, it actually has a lot of connection to the distance formula, and I'll let you ponder that if you're curious. Otherwise, you can just kind of memorize this formula. And then the second one, which is general form. So the equation, put in red, the equation of a circle in general form is x squared plus y squared plus ax plus by plus c is equal to 0. Sometimes it's better, honestly, the best form is standard form, but every once in a while this form might be useful. And I want to add one note on the next page, which has to do with how we go from one to the other. So if we're in standard form, which once again is x minus h squared plus y minus k squared equals r squared, where h comma k is the center and r is the radius. If we want to go, let me actually make this a different color. Let's use blue. Let's use blue. I like blue. And here's general form. Standard form, general form, which is x squared plus y squared plus ax plus by plus c equals 0. So if you want to go from standard form to general form, you just need to simplify. That is, you need to FOIL this out, right? FOIL out the x minus h squared, FOIL out the y minus k squared, and then bring the r squared to the left. Whereas if you want to go from general form to standard form, you have to complete the square. Now, if you remember how to complete the square, that's awesome, perfect. Just go ahead and continue onward. Well, we're gonna do a problem with that a little bit later. But if you don't remember that, or if that's completely foreign to you, there's a video for in the Math 96 refresher section about completing the square. It's also part of, there's something about the completing the square, the square root property, but that video has a very, very good detail on how to complete the square. So please watch that if you need a little bit of a refresher, okay? So let's go ahead and get into some problems, some exercises. So example, write the equation of a circle in both forms with the following info and graph. So part A will be that the center of this circle is at -2, 3, and the radius is 4. Part B will be that the endpoints of a diameter of the circle, that's a terrible writing of circle, are, didn't mean to switch back to that page, of a circle are -4, -2, and 2, 6. So, we'll go ahead and start with part A. So our solution for part A, we know that our center is at -2, 3. Well, that means that our h value is -2 and our k value is 3. And we already know our r value, our radius, which is 4. So we have everything we need, right? The formula for for standard form is x minus h squared plus y minus k squared equals r squared. We have h, we have k, we have r. We can just finish it up. So this will be x, and if you want help memorizing it, remember you can always just rewrite the formula every single time you do the problem. So that's x minus h quantity squared plus y minus k quantity squared equals r squared, which means we have, and I'm just going to go ahead and write the standard form because this is going to be my answer. It's going to be x minus -2, so that's x plus 2 squared, because x minus -2 becomes x plus 2, plus y minus 3 squared equals r squared, which would be 16, because r is 4, and squaring that would give you 16. And as I said on the previous page, in order to convert to general form, we need to simplify. And in fact, we need to do a little bit more than just simplify the left-hand side. We need to bring this 16 over as well, because if you recall, there's a 0 on the right-hand side for general form. So we need to make sure that everything is on the left. So we'll do x plus 2 squared plus y minus 3 squared equals 16. And as a small aside, you don't need to write this down, but I want to remind us that x plus 2 squared is not x squared plus 4. We have to FOIL it. We have to do x plus 2 times x plus 2, and then you FOIL it, right? The same thing goes for the y minus 3. So I just want to remind us of that so that we don't make that classic mistake. So this becomes x squared plus 4x plus 4 plus y squared minus 6x, or not 6x, 6y minus, plus 9 equals 16. We'll bring the 16 over and combine like terms and simplify to get x squared plus y squared plus 4x minus 6y. 9 plus 4 is 13, subtract 16 is minus 3 equals 0, and that's my general form. I'm going to write general form, gen form. So the last step is to graph. Now how do we graph the circle? Now, don't draw this, just to give you some intuition. So, if we have the circle, we don't know where it is. We do know where it is, but it has a radius of 4. So, this distance right here should be 4. But what would this point be? It'd be really hard to figure out. However, there's an easier way to do this. If we go 4 units up, i.e. the radius is distance up, 4 units to the left, 4 units to the right, and 4 units down, you get a very, very nice, neat point that you can plot. The reason why I don't want to plot this point is because even though this distance is 4, this isn't going to be a nice point necessarily. It might be, but very rarely. So the best way to graph them is to plot a point directly above it by the radius. So move up 4 units, move down 4 units, plot those points, move left 4 units, right 4 units, plot those points, and then connect the circle that way. So that's what we're going to do. So we need to plot our center, which is -2, 3, right there. And then we'll move 1, 2, 3, let me make that a little prettier. 1, 2, 3, 4, and right there, right? 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, 4. Right there. And then we'll just connect all those points with a circle as best as you can, right? I'm not one of those teachers who can draw a perfect circle, sorry. And that's our best drawing of a circle. And we'll move on to part B, which is a little bit of a trickier problem. And just, if you're wondering why the verbiage is the way it is, so any line through the center of the circle is a diameter. So that's a diameter, and so on and so forth. So that's why it's saying endpoints of a diameter of the circle. Now, how do I use this information? Because this is not the center, and we don't know the radius. So what do we need? What do we need? Well, if we go back, don't worry, I'm coming right back to this. But in order to find the equation of a circle, we need the center and we need the radius. How can I find the diameter? Or how can I use the diameter to my advantage? Well, let's look at a picture just once again to visualize this. Let's just say the circle is right here, okay? If this is a diameter, right, going straight through the center, half of the diameter is the radius, and the midpoint of this diameter is the center. So we'll use the midpoint formula for the center and use the distance formula for the radius. And you're going to need to divide by 2. You'll see what I mean with this one in a second. So the center for the midpoint, that's going to be x1 plus x2, so -4 plus 2 divided by 2. And then the y components, so -2 plus 6 over 2, which gives us -1, 2. So that's the center, and then we'll get the distance d, which will be the square root of the difference of the x components, so 2 minus -4, or 2 plus 4, because subtracting a negative, same as adding, and then 6 plus 2 squared, which ends up being the square root of 100, which is equal to 10. This is the diameter. So we still need to divide by 2. To get the radius. That is to say, the radius r is equal to 2. The radius is 5. 10 divided by 2, which is 5. Okay, so with that in mind, we can now get the the standard form, then the general form, then graph. So we'll move to the next page. So, standard form. So, it'll be x minus h, and our h value is -1, so it's going to be x minus -1 squared plus y minus the other one is 2 squared equals 5 squared. And simplifying that, making it look a little bit prettier, x plus 1 squared plus y minus 2 squared equals 25. So that's the standard form. For the general form, we need to FOIL it out. So we get x squared plus 2x plus 1 plus y squared minus 4y plus 4 equals 25. And we've got to bring everything over. So we get x squared plus y squared plus 2x minus 4y. And then 1 plus 4 is 5, minus 25 is negative 20, so minus 20 equals 0, and that's the general form. And for the graph, we'll go ahead and add a little nice picture. Boom. And we'll plot the center, which would be negative 1, comma 2, right there. Ooh, I'm going to use a different color. Negative 1, comma 2. And then our radius is 5, so 1, I'll use 1, 2, 3, 4, 5, right there. 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 And then we'll just connect all the dots with a circle and call it good. And that is question B. And we'll do one more problem before we'll go to the extra problems at the end. So this problem is going to have to do with that completing the square. So if you don't remember that, now would be a good time to go back and refresh on it. But our example is find the center and radius of the circle. X squared plus y squared plus 10x minus 8y plus 16 equals 0. That's a circle in general form. So, if we're going to do that, how do we find the center? Well, if we go back to the very first page, don't worry, I'm coming right back. In order to find the center, the general form doesn't tell you where the center is. The standard form does. And the standard form also tells you the radius. The general form doesn't. So the key here is going to be, that looks like keg. The key here is to get in standard form, and we do that by completing the square. For each variable. So, I'm going to just rearrange this so that the x terms are together and the y terms are together, and then the 16 is on the other side. This is how I do it, but there are other ways. So, x squared plus 10x plus y squared minus 8y equals negative 16. Now, I need to complete the square on both of these things. And the way you do that is you look at the b term, you have it, and then you square that. So 5 squared is 25. And then here, the b term is negative 8. Divide that by 2, you get negative 4. Square that, you get negative 4 squared, which is positive 16. So what we do is x squared plus 10x. We're going to add 25 and then subtract 25. And we can do that because that's cleverly adding 0. Like, if you add 25 and then immediately subtract 25, you haven't changed the equation at all. And then we're going to go with our y squared minus 8y. We're going to add 16 and then subtract 16. That equals negative 16. And the reason why we're doing that is this right here is a perfect square trinomial. This is x plus 5 squared. And this is y minus 4 squared. Simplifying everything together, we get x plus 5 squared plus y minus 4 squared. Negative 25 minus 16 is negative 41 equals negative 16. We'll add the 41 to both sides and we'll get x plus 5 squared plus y minus 4 squared is equal to 25. So remember, this is our r squared. So that means that r is equal to technically plus or minus 5, but we can't have our radius be negative, so our radius is 5. And our center comes from these things. So, is the center, don't write this down because I'm going to wonder, is the center 5, 4? negative 5 comma 4, or some other thing. Well, that's where we have to refer to the formula. The formula, I'm just going to write it here for brevity, is x minus h squared plus y minus k squared equals r squared. So, this right here is not in the proper format. It's in the form of y minus a number. This is in the form x minus plus a number. But we can easily bypass that. The way we do that is we just write this as x minus negative 5. So our center is at negative 5 comma 4. So that is our answer. The center is at negative 5 comma 4, and our radius is 5. Okay. So we'll move on to our little extra practice problems, and I've only got 2 today, but I think they're pretty fun ones. So first one is, given the graph of the circle, find its center, radius, and write its equation in standard form. Now, it's not a perfect picture, but assume that these 2 points are points on a diameter, so they go straight through the center. And then the second one is, find the equation of a standard form with center at 2 comma 4 and a circumference of 16 pi. So we'll get started with question 1, which is given the graph, and we already said that, never mind. So, as I said before, we're assuming that this is a diameter, so it's kind of the same thing, it's just this time it's a visual example instead of the previous example, this one right here. Where is it? This one right here. It's the same thing, but it's just in a picture form instead. So, same thing happens, we need to find the center, we use the midpoint. The center is at the midpoint. So that is m is the average of the x-coordinates, 0 plus 2 over 2. And the average of the y-coordinates, 1 plus 3 over 2. Which ends up being 1 comma 2. Then we have to find the diameter, which is equal to the square root. We're going to use the distance formula to compute the distance between these 2 points. So 2 minus 0 squared, or just 2, plus 3 minus 1 squared, which is the square root of 4 plus 4, right? Because square root of 2 is, 2 squared is 4, and then 3 minus 1, that's 2 squared is 4. So this is the square root of 8. And I'm not too concerned with you trying to simplify this at all. It should be fine like this. So, our radius is going to be square root 8 over 2, which technically would be square root 2, but we don't need to worry about that. What we'll do is then we want to find the equation in standard form, so x minus h, so x minus 1 squared, plus y minus k, which would be 2 in this case, squared, equals the radius, which is square root of 8 over 2 squared, which would be simplified x minus 1 squared plus y minus 2 squared. And I'm just going to compute this off on the side, some scratch papers. Square root of 8 squared is 8. The 2 squared is 4, which is 2. So this should just equal 2. And that is the equation of our circle. Thereby completing question 1. Moving on to question 2, I thought this was a pretty cutesy problem. So, center is already given, right? 2 comma negative 4. What's the radius? What's the radius? Well, there must be something we can use, and particularly, it's going to be this. The circumference is 16 pi. So if you remember, the circumference formula is c equals 2 pi r. So, we know what the circumference is. It's 16 pi, and we don't know what r is, but that's what we're trying to find. We're trying to find the radius. So, 16 pi is equal to 2 pi r. We'll divide both sides by 2 pi. The pi's cancel, and the 2 goes into the 16 8 times. So our r value is 8. So then we have our center, we have a radius, we're all set. X minus 2, because that's our h value. X minus 2 squared plus y minus negative 4, so y plus 4 squared, equals 8 squared, which is 64. And that is our answer. Bing, bang, done. All right, guys. Have a good one. I'll see you next time.